Hi everyone. In this video, we'll be talking about the cross product, right? So cross product. So the cross product, if you recall from the two videos ago, is it takes in two vectors, and we denote it with a cross, right? And it spits out another vector, which is three numbers, right? Like x, y, and z coordinates. So let's talk about the numerical first, right? Numerical. How do you numerically calculate the cross product? Right? The cross product. So if we have A, B, C cross D, E, F, then this is equals to, okay, so if you pay a bit of attention, it's going to be equal to BF minus CE, CD minus AF, and AE minus BD. So yeah, that's the cross product. So if you don't believe me, you can search cross product formulas, right? And you see that the cross product is, okay, I'm trying to look for one that is so between A, B, C, and D, E, F, this is the cross product. BF minus CE, CD minus AF, and AE minus BD. So you see that they just wrote it in a horizontal manner, but it's actually the same thing. So they wrote it like that. There's a couple of ways to remember the cross product. I'll leave it up to you to search whatever method you want. There's some people who write it in a form like that, and then they use this thing, which is actually a determinant of a matrix. There's some people who have some certain memorization. Some people call this a shoelace method, right? And other people, they just remember it by heart or something. But I'll leave for you to research about the way you want to memorize it. But the way I look at it is I look at the first component, right? So for the first one, it's going to be for the first one is going to be BF minus CE. Then the second one is going to be CD minus AF. And then the third one is going to be the Z component is going to be AE minus BD. So that's how I remember it, but it's up to you how you want to arrange it. So let's go through an example, right? So it's good to go through examples. So for example, we have A equals to 2, 3, 1, and B equals to 1, 2, 3. So then A cross B equals to 3 times 3 minus 2 times 1, that equals to 9 minus 2, that's 7. Then the next one will be 1 times 1 minus 2 times 3, so that's minus 5. And the last one will be 2 times 2 minus 3 times 1 equals to 2 times 2, I wrote it, 2 times 2 minus 3 times 1 equals to 1. Okay, so that's the numerical picture, and you see the numerical picture is quite straightforward. It's just a little bit of memorization. But what is a geometrical picture? The geometrical picture is pretty interesting. It requires the third dimension to visualize. So if you have two vectors A and B, then if you take the cross product of them, the first step is to imagine the plane they span. So what this means is that imagine the two vectors, right? They lie in a single plane. So imagine that there's a plane that they span. I'll talk more about this later, right? And then imagine that now you have the plane. Imagine that from where they originate from, there's a normal vector to the plane, right? A vector that's 90 degrees to it, sticking out. And so this normal vector is precisely the cross product. So it's best to come over to the visualization. So if I go ahead and open my cross product visualization, okay, let's go ahead and edit it. Okay, yeah, it took a while to load, but now it's loaded. I'm not sure why it's off-centered. Let me just reload it. Okay, it's a bit wonky, but never mind. So if I have the vectors, okay, it's a little bit difficult to see. Okay, so let's say I have the vectors 1, 2, 3 and 3, 3, 3. Okay, so the vectors 1, 3, 3, 3, 3, 3 and 1, 2, 3. And yeah, so let me just go ahead and close this. So if I have the vectors 1, 2, 3 and 3, 3, 3, then they are, what I mean by the plane that's spanned by them is that if you look at the two vectors and you think of a two-dimensional plane that's passing through both of them, that is the plane that's the plane that they span. So if you look around, right, you can see that the both vectors lie on the plane. Then what is the cross product? The cross product is going to be this. So the cross product, if you calculate it numerically, right, 3, 2, 3 cross 1, 2, 3 is going to give you 3 minus 6 and 3. The cross product is the normal vector to that plane. So if I look at the plane, right, now I move it to the angle where the plane is just a thin slice through, it's just a thin slice because I look at the plane from the side. You see that the cross product is perpendicular to the plane. And look at the plane from another angle, right, any angle that we look at the plane from, the cross product is always 90 degrees to the plane, because that's what it means for the vector, the cross product, to be the vector to be perpendicular to the entire plane. So if you have a 2D sheet, right, then you can have a vector that is perpendicular to it. So yeah, that's the geometrical picture of the cross product. So perhaps I could elaborate a bit more. Yeah, so okay, so that's for the direction. So we know the direction, but what is the length of the cross product? So the length geometrically, we have A cross B is equals to the length of A times the length of B sine theta times the normal unit vector. So this is the normal unit vector, which means that a unit vector is length 1. So the unit vector to the plane would be the vector that there are two such vectors, right, pointing in opposite directions, but there's a sign convention to go with it. So it will be a vector that's pointing in the perpendicular to the plane that is spanned by both of these A and B vectors, and so this tells you the direction. So this n hat, right, is called a hat, n hat. It tells you that the hat tells you that it's a unit vector, and the n indicates a normal vector. So this tells you the direction, and then the term here will tell you the length. So this is the length. So the length is the length of A times the length of B times the sine of the angle between them. So if the angle theta equals 90, right, then the length of the cross product is maximized. So yeah. Okay, so now to talk about the sign convention. For if we draw a plane, right, then there are going to be two vectors that are of unit length and normal to the plane. So one is something that looks like that, and the other one will be negative of that direction. And the question is, which one do we choose? And the answer is, we choose according to the right hand rule. So if you search up the right hand rule for the cross product, right, So for the cross product, to determine the direction of the cross product, you take out your hand like that, and then the second finger and the third finger, right, the second finger and the middle finger are your vectors A and B, as seen in this diagram over here. And then your thumb will be perpendicular to both of them, right? And the thumb will indicate the direction of A cross B. So that is how you tell the direction. Alright, so that's the geometrical picture for the cross product, and we have also seen the numerical picture of calculating the cross product. So yeah, it's a bit of a handful to take in, no pun intended, but using this GeoGebra example, right, we have calculated B cross A. We can see that the cross product is in fact perpendicular to A cross B, right? Is perpendicular to the plane spanned by the vectors A and B. Okay, in all directions, you can see that it's a 90 degrees. Okay, so I hope that this example has this visualization has helped you visualize it better. And if not, we'll be talking about the applications of vector cross product in the next video. Have a nice day. Bye.